and we're going to be dealing with area of a triangle and then the law of sines. So I want you to recall back to secondary math 1 and 2. We were only dealing with right triangles, and we know how to find the area of a right triangle because we know the formula, which is great to know, because if you have a right triangle, you're going to want to use this formula. So you know if you have a right triangle, now guys, right means 90-degree angle involved in the triangle. Does everybody see what makes this a right triangle? So if you have a right triangle, such as this or this, now this is it has a right angle in it, you can find the area by taking 1/2 times the base times the height. This is not new to us. Area is equal to 1/2 times the base times the height. We've learned this in secondary 1 and 2. Does everybody, that is a very familiar formula, right? Okay, so pretty awesome, pretty easy. So like for example, looking at this, we know it's a right triangle, and if I said to you, find the area, you'd say, okay, I know that that's, because there's a right angle, its area is equal to 1/2 times the base times the height. So I wrote that down. 1/2 times base times height. I plugged it in, just showing you what I would do here. So 1/2 times the base, which is 3, times the height, which is 7. Oh, I put 2. So we're changing this to a 2, not a 7. Okay, so that's a 2. So 3 times 2, so we have 1/2 times 6, because 3 times 2 is 6. So our area of this triangle would be 3. Pretty easy, right? This is not new. Now, what if we're looking at something like this instead? So looking at this, does everybody see how we have a line drop perpendicular? When I say that, that means drop down to a 90-degree angle. Does everybody see it? So I have this triangle, and I have a perpendicular line drop down with a 90-degree angle. So if I said to you, find the area, you'd say, I'm going to use 1/2 times base times height. Well, what if I gave you this kind of triangle? And I said to you, okay, find the area of this. Well, we have a base, but do we have a height? No, right? If I said, I could say, I'm going to drop a line down perpendicular and call that H. Now, with that being said, though, we would have areas equal to 1/2 times 10 times H. Now, don't we have a variable that we have no idea what it is? So that's what the formula I'm about to give you for. It's for something like this. So we have a triangle. We don't have a 90-degree angle involved at all. So to find the area of that, you're going to use this formula. It's the area, and it's involving sine. So does everybody see this triangle? This is angle A, this is angle B, this is angle C. So a couple of things before we get into this that you just have to know. Angles are written with capital letters. Does everybody see how at the vertices of my triangle are written with capital letters? This is angle A. Yeah, everybody? Angle B and angle C. Now, across from the angle is the corresponding side. So if this is angle A, this is side A. Does everybody understand that? It's across from angle A, so this is considered side A. Now, you always write sides as little letters. So because this is angle C, this side would be considered side C. Because this is angle B, this is side B. Does everybody see the triangle? So if I asked you to find the area of something like this, there's no right angles involved. Unless you're given for sure that there's a right angle, you can never assume, even if it looks right, that this is a right angle. So this is the formula for that. 1/2 times B times C times sine of A. So once again, area for any triangle, and this will actually work for any triangle. So area, to find the area of any triangle that's not right, or if it's right, you just use 1/2 times base times height. But this is how you find the area of any triangle. 1/2 times B, side B times side C times sine of A. So this is side B, side C, and then sine of angle A. So notice something, side B and side C. Do you see how angle A is between those? Okay, now it's the same thing as saying, okay, area is equal to 1/2 times side A times side C times sine of B. Now look, side A, side B, do you see how angle C is between? Okay, and then area is equal to 1/2 times A times B sine of C. Oh, I wrote that. No, A and B sine of C, that was what I just said, sorry. And then A and C sine of B. So A and C, do you see how the angle in between? So I don't even write out the formula like this. I write it out just like I do with the Pythagorean theorem. I don't like having all these variables. Really, we just think about what it means and it makes it easier. So in general, I'm going to say this. So area of a triangle is 1/2 times side 1 times side 2 times by sine of the angle in between. So angle in between those two sides. Because that's a lot easier than memorizing all three of those, right? So side 1 times side 2 times by sine of the angle in between those two. I'd rather remember that than all the formulas and trying to say, oh, AB, because what if it was FBH? Then people start to say, well, what side's A and B? But it's not, it's what it means, not what side A is, what side B is, what side C is. Does everybody see what I'm saying here? So this is the formula that I always write down and have memorized. Okay, so let's go. So it says, find the area to the nearest tenth. So looking at this, do you see how we have a side 1, side 2? And we have the angle in between. So we would say, we know area is equal to 1/2 times side 1 times side 2 times by sine of the angle in between. So I'm just going to say A sine of A. Angle in between. So we have area is equal to 1/2 times side 1, doesn't matter, so I'm going to say 10 times side 2, which is 5, times by sine of the angle in between, so sine of 31 degrees. Now to type it into your calculator, notice in the original problem we're dealing in degrees, right? So your calculator needs to be in degree mode. So everybody, hit mode, make sure your calculator's in degree mode, and then you're just going to type it in. So type it in your calculator, and if you do, type it in, you get 12.9. So area is equal to 12.9. That's the area of my triangle. This is a formula you'll have to have memorized for the test. It's not that hard though, but yeah, it's going to take a little bit of memorization. Questions on how to do that? Wasn't it pretty easy? Okay, so with this one, we'll find the area. So we have side 1, which is 6 centimeters, times side 2, which is 8 centimeters, and then sine of the angle in between, so sine of 51 degrees. So I type it in, 8 times 6 times sine of 51, and you get 18.7. So our area of the triangle, now area means I could fill it in, right? You guys all understand what area means, I hope. Okay, so area is equal to 18.7. Now you need to be able to actually state, and especially at this level, like, are we dealing in centimeters? Well, look, didn't we multiply a centimeter and a centimeter? So it's going to be centimeters squared. So you get 18.7 centimeters squared. The centimeter squared part doesn't change your answer. That's just your units of measurement. Do you understand that? Yes. Add a 1/2. Thank you. Sorry, I was just using this and yeah. So don't forget the 1/2. Sorry about that. So if you typed that in without the 1/2, you wouldn't have got 18.7. So did that help everybody? Sorry. 1/2 times 6 times 8 times sine of 51. Thank you for fixing that. Did everybody get 18.7 when you typed that in? Okay. Awesome. Are you ready to do it by yourself? Okay. I need you to write down the units of measurement correctly. Okay, so do 1 through 4. Ready, set, go. If you were to see something like this, for example, on an ACT test, and they said find the area of this, and you said, oh look, I have a height, I have a base, 1/2 times base times height. Did we know that this was a 90-degree angle? No, we weren't told it was, so we can't assume it is. So therefore, it would not be correct to use 1/2 times base times height. Instead, we'd say, oh, I know now the formula to find the area of any triangle. So we would have said area is equal to 1/2 times side 1, which is 3, right? Times side 2, which is 7, times by sine of the angle in between. So we'd say sine of 35. That's how you'd appropriately find that one. Does that make sense, everybody? Okay, awesome. All right, moving on. Okay, so the area for a triangle, that formula actually yields like the formula for the law of sines. Now, this is the one that 90% of you will see on an ACT test. If you take the ACT test more than once, you will all run into one of these problems, the law of sines. It's huge. So the law of sines says, this is the formula for the law of sines. So now, just barely a second ago, now don't write this down, isn't this the formula for area of a triangle we just talked about? A times B times sine of the angle in between, right? Or we could say 1/2 times A times C times sine of the angle in between, which is the same thing as 1/2 times B times C times by sine of the angle in between. So now this is algebraically where the law of sines comes from. So if we took all of these and we divided them all by 1/2 ABC, divide by 1/2 ABC, divide by 1/2 ABC, let's look and see what we get left. So we would have the 1/2s divide out, right? The A's divide out, the B's divide out. What's left? Sine of C over, so sine of C over C. That will be equal to, look, our 1/2s divide out, our A's divide out, our C's divide out. What's left? Sine of B over B. So we have sine of B over B. And then we keep going here. 1/2s divide out. The B's divide out. The C's divide out. Left is sine of A over A. And that is where the law of sines comes from. This is the law of sines. Sine of C over C will be equal to sine of B over B, which will be equal to sine of A over A. So I'm just going to go to my next slide, which has the same thing. So you can use the law of sines to find missing angles and lengths of a triangle. So you can find missing angles and missing side lengths using the law of sines. So once again, it's sine of angle A over A will be equal to sine of angle B divided by B will be equal to sine of angle C over C. These ratios will be equal. Now you don't have to use all three. You'll usually just use two of them, because then you'll have an equation you can go ahead and solve for missing sides. Now if you have a right triangle, I don't think I put this in there, we find missing side lengths like 2 and 4. We find missing side lengths using the Pythagorean theorem, right? Everybody? Now here's the catch. This is what 90% of students will do on an ACT test. They'll be given a triangle that was not specified to be right, and they'll be asked to find a missing side length, and they'll use the Pythagorean theorem. But unless you have a right triangle, you cannot use it. Instead, you would use the law of sines. Does everybody understand what I'm saying? So you would never use the right triangle Pythagorean theorem or right triangle trig to find missing side lengths unless you know for sure it's a right triangle. So now you know law of sines, and that always works. Okay, so now this is when you're going to use the law of sines. So these are the 3 times that you'll use the law of sines. So if you're given 2 angles and a side, you'll use the law of sines. So any 2 angles and one side, any side, you can use the law of sines. If you want to take a picture of this, you can. Also, if you're given 2 sides, so take a picture so that you can listen. So while I explain, you can have a situation. So I need you to listen so that you really understand and grasp what I'm telling you. So you can use the law of sines given any 2 angles and one side. So if you have 2 angles and a side, then you can use the law of sines. Okay? Now, isn't it easy to find the 3rd angle of this triangle? You just do 180 minus that angle, right? So then you could use the law of sines. Now, this is the next one. If you're given 2 sides and an obtuse angle, obtuse means greater than 90 degrees. So if you're given 2 sides, such as 10, 6, and an obtuse angle, does everybody see how we have 2 sides and an obtuse angle? As long as the obtuse angle is across from one of the sides. So do you see how this obtuse angle is across from one of the sides? So that's when you will also be able to use the law of sines. And then also, next thing, you can use the law of sines if you're given 2 sides, so once again 6 and 10, and an acute angle. Acute means less than 90 degrees. So if you're given an angle less than 90 degrees, and you're given 2 sides, you can use the law of sines as long as that acute angle is across from the side that's larger than the other side. Does everybody see how this is 23 degrees? So it's an acute angle. It's across from 10. Is 10 larger than 6? So we can use the law of sines. Now if we would have flipped that and had the 6 here and the 10 here, we have an acute angle across from 6. Is 6 larger than 10? No. So we could not use the law of sines. Okay. Okay, it'll get easier with time, okay? So looking at this one, it says, what is RQ? So once again, you can use the law of sines to find angles and side lengths that are missing. So everybody, on my first example, I'm finding what is RQ. So I like to go ahead and put in an X on what I'm trying to find, because it just makes it easier than writing RQ in my equation. So I'm trying to find X, which is right here, right? Does everybody see that? Now let's ask ourselves on every problem, can I use the law of sines? Because on the ACT, they're not going to say use the law of sines. You're going to be given a problem and have to determine if you are using the law of sines or not. So, looking at this, can we use the law of sines to solve for that side? we're given two angles and one side. Can we use the law of sines? Yes, that's one of the criteria. Okay, awesome. Any questions up to here? So now the law of sines says, okay, we can take, now this is angle R, right? So this is side R. This is angle Q, so isn't this side Q? This is angle P, so isn't this side P? Okay, so the law of sines says we can take sine of angle P divided by side P. That will be equal to sine of angle, I'm randomly choosing Q over side Q, which will be equal to sine of angle R over side R. So I set up my law of sines. Now I'm going to put in what I know. So I'm obviously going to use this angle, right? Yeah? Okay, and we have that side. So this is R. So we have sine of angle 39 over 40 will be equal to, now look, aren't we trying to find x? So won't we need this angle and then this side? Yeah. So can we find that angle pretty quickly? Okay, let's find it. 180 minus 39 minus 32. What was it? 109. So we have 109 degrees. So we know that sine of 39 over 40 will be equal to sine of 109 over x. Now you don't have to use all three. You can just use 2. In fact, we'll just use 2. Now look at that. Is there just one unknown in my equation? Can we now just algebraically solve for x? Yeah? Okay. So let's algebraically solve for x. But any questions on how I set this up? Okay, so now let's algebraically, like I said, solve for x. So I'm dealing with a bunch of fractions. I personally would rather not. So I'm going to cross multiply. So I'm going to multiply both sides by x. But doesn't the x divide out over here? Then I'm going to multiply both sides by 40. But then doesn't my 40 divide out? So I algebraically have x sine of 39 degrees is equal to 40 sine of 109. Questions on that? Now we're just algebraically solving for x. So we're trying to get x alone. Now let's look. Isn't x multiplied to sine of 39? What undoes multiplication? Division, right? Yep. So we'll divide both sides by sine of 39 degrees. Divide by sine of 39 degrees. Now look, sine of 39 divided by sine of 39 is 1. So we have x is equal to 40 sine of 109 all over sine of 39 degrees. Now, x is alone. We solve for x. Type it into your calculator. It's going to give you the answer. 60.1. All right, 60.1. So we got x is equal to 60.1 degrees. That is correct. Now you can look at your picture. So 60.1 degrees. Oh, not degrees. Why did I write degrees? That wasn't an angle. That's a silence, right? 60.1. Everybody good? Now look, you've had to check your answer to see if it makes sense. So isn't 109 the largest angle? It's really quite big, and that's a pretty large side. So looking at it, do you see how that side is larger than across from the 39 degrees is a smaller side? So do you see how you can kind of look at your picture and see if it makes sense? Because it wouldn't make sense to have, because angles correspond with sides. So if we had side 20 and angle 109 with the side across from it being 20, well, if it's a bigger angle, it's going to be a bigger side. Does that make sense, everybody? So 20 would have been smaller than 40. We know we've done something wrong. So your picture should kind of make sense. Does everybody see how to do that? Okay, let's do one more. Then I'll let you practice. So looking at this one, we're asked to find x. So this one we're asked to find x. So you first ask yourself, how am I going to find x? Well, I'm going to use the law of sines. I'm given two angles and one side, right? So I'm going to solve for x. So I set up my law of sines. So I know I can do sine of 80 degrees, right, over x better be equal to, well, don't we only have side 10? Yeah. So don't we need the angle right here? Well, can't we find that quickly? Okay, 180 minus 80 minus 35. 65 degrees. So we know that sine of 80 degrees over x will be equal to sine of 65 over 10. And now we'll algebraically solve for x. Questions on how I set it up? Okay, so we'll cross multiply. I'm going to multiply both sides by x, but it divides out on this side, right? I'm going to multiply both sides by 10, but the 10s would divide out over here. So we have 10 sine of 80 degrees is equal to sine of 65 degrees times x. Now to get x alone, it's being multiplied to sine of 65 degrees. So won't I just divide by sine of 65 degrees? X is alone, so type it in. 10 sine of 80. Hit enter, then divide it by sine of 65. You should get 10.9. So you get 10.9 is equal to x. Now let's make sure our picture makes sense. 80 degrees is larger than 65 degrees, right? 10.9 is larger than 10, so we've probably done it correctly. Questions on how to do this, something like this. So notice we found missing side lengths with using the law of sines. Okay, so I'm going to have you practice finding missing side lengths using the law of sines. So these are the problems you're doing. 6, 8, and 11. On 11, don't just say, oh, I can't do it. I guarantee you can do it. Everything you need is there. If you need a hint, look up here. Don't just say, I can't do it. How do you do it? If I tell you how to do it, you didn't have to think through it. I need you to really try number 11 without asking me, how do you do it? Okay, ready, set, go. So we were just barely using the law of sines to find missing sides. You can also use the law of sines to find missing angles. So looking at this, everybody, this one you have to pay really close attention to little details. I'm telling you. Listen up and pay attention to my little details. So, looking at this triangle, let's see if we can use the law of sines. So, we're given two sides and an angle, right? Isn't it an acute angle? Now, is the acute angle across from the side that's larger than the other side? Yes, so we can use the law of sines. So let's set up the law of sines. So we know it's sine of the angle, so sine of 43 degrees, over the side across from it. Now look, isn't the side across 28? That will be equal to, we know it will be the sine of that angle, right? Across from, divided by the side across from it. So we have is equal to the sine of x divided by 27. Now make sure you look in your equation. We only have one unknown. Yes. Does everybody see how I set that up? Now let's algebraically get x alone. So, to get x alone, this 27 is being divided by sine of x, right, everybody? So I'm going to multiply, now watch carefully. I'm going to multiply both sides by 27. Both sides, right? But what happens on this side? Divides out, right? Is everybody following me? So on this side, we have 27 sine of 43 degrees divided by 28, right? And that's equal to the sine of x. Okay. Questions up to here. Now look at our x. Isn't it entrapped in sine? The only way to get that sine to go away is to take the inverse of it, which is inverse sine. So we're going to take the sine inverse because x is entrapped in. It's not multiplied, right? It's entrapped in the parentheses. So we're going to take the sine inverse, and you've got to do it to both sides of the equation. So I'm taking the sine inverse of this side and the sine inverse of this side. Now guess what happens? If you take a sine inverse and a sine, they cancel out. So on the left, I have sine inverse of 27 sine of 43 divided by 28 is equal to, and now the inverse sine and sine cancel out, is equal to x. Isn't x alone at this point? Now we'll just type it into our calculator. So you do second sine, because that will give sine inverse. Now you all should practice typing it in, because just a couple of things to be careful of. So you'll go second sine, because that puts in sine inverse. Now type in 27 sine of 43. Now notice you need to close your parentheses around the 43. Does everybody see that? Now hit divide 28. Then you need to close your parentheses, hit enter. So 41.1. 41.1. So that's equal to x. So our angle is 41.1 degrees. Now your picture should make sense. Isn't this my smaller angle? Was that my smaller side?
Yep.
Is this my little bit bigger angle? A little bit bigger of a side. Okay, so your picture should make sense. Does everybody see how to do that? Do you need one more like that and then I'll let you work? Okay. So, this time it's in words. So it says, in triangle RST, side T is 7, side R is 9, and it says the measure of angle R is 110 degrees. Then it's saying, what's the measure of angle S? So I have to be able to draw the picture correctly here. So I don't even care what my triangle looks like. I'm going to just like draw one in. Is everybody, it's not going to be drawn to scale necessarily, but who cares, right? Okay, so I am going to name it though RST because I need to label it correctly, otherwise you'll get it wrong. So now we know side R is 9. So across from angle R is side R, so this is 9. Does everybody see how I'm filling it in? This is side T, across from angle T would be 7. And it says the measure of angle R is 110 degrees. So I go to angle R and I'm writing in 110 degrees. Now it's saying what's the measure of angle S? So I'm going to put an X there. And now it's the same as just before. So let's set up, now I'm going to once again say, why can we use the law of sine? We have two sides and an obtuse angle, right? The obtuse angle can be across from any side, it doesn't matter. So we're good though. It is across from a side, right? So we can use the law of sine. So let's go ahead and do it. So we have sine of 110 degrees over the side across from it. That ratio will be equal to the sine of, did I write that wrong? Because, oh, this is a good one to do. Okay. So okay, let's see. So we don't know this side, right? So we would have sine of x over question mark. Can we solve this one using the law of sines? Nope. We don't have enough information. So we would say, can't solve. Because if we have, can we even find this angle? No, because we have no idea what this is, right? So this one we can't solve using the law of sines. Okay. You will run into that. This is a good example.
So like on the ACT, we run into something like that, we just write can't solve?
No, we're going to learn the law of cosines tomorrow or Monday, and you would use the law of cosines in this problem. Yeah. So then, like, I always choose the law of sines over the law of cosines, but you'll run into something like this, and that's when I say, okay, I'll use the law of cosines, which we'll learn. Yeah, good question. Okay, so do we need one more with the law of sines, or if I keep this up, you think you could go for it? Okay, let's just go for it. We only have 10 minutes left, so ready, set, go.